Hi guys, this is Mrs. Dietrich. How you doing? These are the notes for 7.3, the Pythagorean theorem. Pretty famous formula by a pretty famous guy named Pythagoras. I hope you had a chance to watch the extra video this week. I thought that was a great explanation of how Pythagorean theorem came about. And the cool thing about it is there's more than one way to explain it. Hey, maybe by the end of this you'll have your own as well. A couple famous presidents had their own interpretation of it. There's one that actually, it's in the video if you watched it, and this is actually one of the activities in our book, and unfortunately I can't have you really do all the hands-on things, but I thought this was really neat where I can kind of show you roughly about what's going on. So again, I did my drawings the best I could. So Pythagorean theorem has to deal with right triangles. It can only be a right triangle. It can't be an obtuse triangle. It can't be an acute triangle. It has to be right. So if you can envision a right triangle with side A, B, and side C, right? So then what I did is I just drew these squares that's connected to the side A. So this would be A squared. This side's connected to the B side. So the area of this would be B squared. These are supposed to be squares. So kind of use your imagination in terms of what they represent. If this side's C, then my area here would be C squared. So why in the world is A squared plus B squared equals C squared? It's not very clear from this one. But if you come down here, and again, this is in that cartoon video that I put up. If you take C squared and you put these four triangles, okay? So in this activity, if we would have done it in class, I would have told you to construct 8 triangles, right? And then we would organize them in such a way that I would have C squared with 4 of them, and then I would have A squared and I would have B squared, and I would put the other 4. So why is the left equal to the right? Well, if you think about it like an equation, when you have the same thing happening on both sides, it actually cancels out. So like this cancels with this one cancels with this one cancels with this one, and this one cancels with this one. And believe it or not, you're left with C squared equals A squared plus B squared. So A squared plus B squared equals C squared. So promise you would have been way cooler had we done it in class, but you kind of get to still see it. And again, it was on that video, and I'm sure the video did a better job than me, but just to kind of give you a visual of why this happens. And again, there were other proofs explaining it. The good news about it is I'm not going to ask you, prove this to me. I'm going to ask, now that we know where it comes from, we're going to use this to solve problems that involve right triangles. All right, so in words, in any right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. So in your notes, and I probably should have just done this first, so when you have a triangle, it really doesn't matter which one's A and which one's B. Like once you make that decision, like I could have said that's B and I could have said that's A. C is the hypotenuse, which is always going to be opposite the right angle. This, you don't have a choice in what C is. This could be AB and this could be BA, it doesn't matter. So your two shorter legs are going to be your A and B. The longest side is going to be C. Okay, so the formula is A squared plus B squared equals C squared. So I'm going to write out my formula because that's what I do. Okay, write out the formula before I use it. So then I want to find the C side, which is the hypotenuse. So again, A and B, it doesn't really matter. So I'm going to do 5 squared plus 12 squared equals C squared. Square 5, I get 25. Square 12, I get 144. Equals C squared. 25 plus 144 is 169 equals C squared. So in order to get C from C squared, we talked about this a little bit, you have to square root both sides. So you get 13 meters on that. The next one, so I'm trying to find the hypotenuse, which is C. So I'm going to do A squared plus B squared equals C squared. I'm going to do 3 squared plus 4 squared equals C squared. So I'm going to get 9 plus 16 equals C squared. I'm going to add them. So in order to get C from C squared, I got to square root both sides. Whatever I do to the one side, I have to do to the other. So I believe it's 5 inches for that side. All right, in example 2, we're finding a missing leg. And actually, one example we're finding A, one example we're finding B. Again, I mean, even if I had B here and A there, it wouldn't matter. You're still solving for one of the legs. So when I do A squared plus B squared equals C squared, A I don't know, so I'm going to leave it A squared. Plus, this must be my other leg. So 2.1 squared equals 2.9 squared. So A squared plus, so you can do 2.1 squared, 4.41 equals 8.41. So in order to get A by itself, you have to isolate A squared. So I'm going to minus 4.41. Okay, so A squared equals 4. And then got to square root both sides, so A equals 2 centimeters. Okay, the next one, we're going to find B. Again, it's just one of the legs. I mean, it really could have been labeled A. Really doesn't matter. So I know the hypotenuse, and I know the other leg I have to solve for B. So I'm going to do 7 squared plus B squared equals 25 squared. So 7 squared is 49 plus B squared equals 625. If I subtract 49, because I got to isolate B squared first. Okay, B squared equals 576. Square root both sides. You get 24 feet is equal to that B side. Hopefully you can see that. Alright, so in this next example, you are playing capture the flag. You are 50 yards north and 20 yards east of your team's base. The other team's base is 80 yards north and 60 yards east of your base. How far are you from the other team's base? So, not that my picture looks just like yours, but I at least wanted to get the shape in terms of the coordinates. So you are at 2050, and then the other base is at 60, 80. So the question is, I don't know if you can see it, but yes, we are forming a right triangle. So the question is, what is the vertical distance, and then what's this horizontal distance? So that's what our task is to do. And I think it is labeled on your graph, but I want to talk about why. So if this starts at 20 and this is 60, so from 20 to 60, how much does that span? So just do 60 minus 20 and you get the 40. So this side's the 40. Okay, so if this is 50 and then this is at 80, what is the vertical distance? Well, if you do 80 minus 50, you get 30. So those are your legs. Okay, so your job is, we got to find the distance from here to here. So we got to figure out your base from the other base. So this is a Pythagorean theorem problem. So I'm going to write out my formula. So I'm going to do 40 squared plus 30 squared equals C squared. 1600 plus 900 equals C squared. So I'm going to combine the two and get 2500 equals C squared. So in order to get C by itself, you have to square root both sides. So the square root of 2500 is 50 yards on that one. So the next question says, what's the distance between the actual bases? So your base, and let me flip back, you'll notice your base, you're at 0, 0. So then the other one is at 60, 80. So the question is, what is the vertical distance? And what is the horizontal distance? That's going to help you figure out the right triangle that's basically underneath the hypotenuse, basically. So you want to know from here to here, what's the distance? Well, think about it. We don't move diagonally on the coordinate plane, so it's not like you could measure that. However, if you take the horizontal and the vertical distance and do Pythagorean's theorem, then you'll find the hypotenuse. So this part's 60 and this part's 80. So I'm going to do 60 squared plus 80 squared equals C squared. So 60 squared is 3600. 80 squared is 6400. If you sum those, you get 10,000. So in order to get C from C squared, you have to square root. So you get, I believe it's 100 yards. you get 100 yards for that. All right, example 4, find the missing length of the figure. So it's a little bit more involved than just doing Pythagorean's theorem like right away. So we kind of have to look at the picture, because if, to me, this is the hypotenuse, this is a leg, and that's a leg. Well, I don't know what that is because there's no number, but the key is the same tick mark. So this part, this leg is attached to this square, and this tick mark, which is 1, is 12, so that means the whole thing is. So this part's 12. So when you do a squared plus b squared equals c squared, now I know that leg, 12 squared plus x squared equals 20 squared. Okay? So then I could simplify 12 squared is 144 plus x squared equals 400. I got to get x squared by itself. So I'm going to subtract 400 minus 144 and get 256. Got to square root both sides, and x equals 16 centimeters. So this part is 16 centimeters. All right, last one. So we have to find the value for x. So not sure if you know where to start, but maybe this will help you out. I'm going to draw a dash line here, and all of a sudden that becomes a right triangle. So if I know this whole side's 13 and I know that part's 7, if I do 13 minus 7, this part's 6. And then if I want to get this leg, okay, I know this whole side's 16. If that part's 8, if I subtract out the 8 from the 16, I get 8. So that side's 8. So now, real quick, that's not really the best. It's a 6 by 8 by, and we got to figure out the hypotenuse. So I'm going to do a squared plus b squared equals c squared. So 6 squared plus 8 squared equals c squared. 36 plus 64 equals c squared. Sum them, you get 100. Square root, you get 10 centimeters for that missing side. All right, so that completes the notes for 7.3. Don't forget to do the try problems on notebook paper. I'll be posting those answers soon. If you have any questions, don't hesitate to email me or pop into my Google Meet. And of course, I happen to have a bad joke. So why is the obtuse triangle always upset? Because it's never right. All right, take care, guys. Talk to you soon. Bye.